Hey everyone, I think we should start. Thank you everybody for joining.
Okay, hello everyone. My name is Belitski. I'm the Vice President of SPAN EA. Let me start with a little introduction about our organization. So SPAN EA was founded by Syrian professionals with a vision of assisting international student professionals in navigating the licensing process in Canada without having to struggle alone. Since its inception in 2014, we have grown into a network of Arab professionals who volunteer and support newly arriving professionals from various fields in integration their careers in the Canadian workforce. Our goal is to empower international professionals, regardless of the background, to enhance their opportunities in Canada through research, education, team building, and other necessary skill sets that contribute to the profession and the built environment in Canada. We also serve as a hub for collaboration and knowledge exchange. And now let me introduce our speakers today, Mike and Bree. Mike Taylor is a registered architect and certified passive house designer with 15 years of experience in architecture, who specializes in high-performance building while integrating low-carbon design strategy into every project. Mike is also, excuse me, let me just go to the other slide. Okay. Mike is also in the education space, teaching innovative approaches and zero building during architecture design studios, alongside educating classes on high-performance building envelopes. Breanne is obsessed with building a climate-positive and low-carbon future. Holding a master's degree in building science from TMU, she is dedicated to decarbonizing the built environment through research, communication, and collaboration. Working with diverse groups, she advocates for the use of bio-based building materials and circular strategies in order to reduce the impact of the built environment and turn resource-heavy industry into one that regenerates the earth. Thank you, Mike and Breanne, for taking time to share your expertise with us today. We'll now hand it over to Breanne to begin the webinar.
Thank you so much, Mojdi, and thanks to SPAN EA for having us here today to talk to you guys a little bit about carbon and the built environment. So I'm going to start by sharing my screen. And I'm going to confirm that you guys are looking at the full screen. Fantastic. Thank you so much. All right, Mike, why don't you kick us off?
Thanks, Breanne. So welcome, everybody. I'm not used to do this online, so we're going to do it as best as I can. And usually I've got a classroom. I'm dancing around at the front of the stage. But if you don't know me, my name is Mike Taylor. I'm a professor of architecture and sustainability at Humber College North in the Faculty of Applied Sciences and Technology. I've been doing things in architecture for about 15 years. And we want to start by saying I make up one half of a brand new consultancy here in Toronto that we have named Heavy Climate Consulting. And it's co-founded by myself and my wonderful co-host, Breanne Belitski. And we bring together expertise in architecture, building science, and decarbonization to tackle one of the biggest challenges in the built environment, which is, of course, carbon emissions. So our mission is to create buildings, to help create buildings that actively work to undo the impacts of human-caused climate change. And we're dedicated to helping architects, developers, and organizations like yours, others, everybody, to take the lead on crafting buildings towards a zero carbon future. So if you're interested, check us out at heavyclimate.ca. Great. And so today we want to talk a little bit about carbon literacy. So the idea of carbon literacy, what is it? And just defining it, even starting with that, is what is carbon literacy? And it refers to the knowledge and understanding of carbon dioxide's role in climate change and how individuals like us, like yours, like everybody can help reduce their overall carbon impact. So as building professionals, it's extremely important for us to understand the impact of carbon because according to the UN, 40% of worldwide carbon comes from our built environment. So we're here today to offer either a refresher, maybe something new about what carbon is, what it does, the challenges it presents, and how we think buildings can serve heal the planet, serve to heal the planet. Next slide, Breanne, I think. Just a quick little agenda for today. So we've got some key takeaways, some key agenda items here. We've got a little introduction to carbon and climate change, a little bit on climate legislation and some key concepts related to carbon literacy, carbon in buildings themselves. So what is carbon doing there? How is it being used? How is it being created? And then what the kind of future of carbon looks like and how do we transition to low carbon buildings? So just before we start, at Heavy Climate Consulting, we recognize that we are situated on the traditional territories of the Mississaugas of the Credit First Nation, the Haudenosaunee Confederacy, the Anishinaabe, Nation, the Huron-Wyandot, and the Métis Nation. We acknowledge and deeply respect how these communities have honored and sustained the land through generations, embodying practices that are regenerative, respectful, and harmonious with nature. So inspired by these enduring stewardships, our work at Heavy is committed to fostering a built environment that not only minimizes the impact, but also enhances and regenerates our natural surroundings. So we express our gratitude for the opportunity to share this land and pledge to pursue our endeavors in a manner that respects and reflects the principles learned from its original caretakers. So thank you for that. And I'm going to hand it off to Bree to do a little understanding carbon part one of our story about carbon literacy here. So it's off to you, Bree.
Awesome. Thanks, Mike. So we want to start by explaining some of the basics of carbon and how it impacts climate change. As I attempt to advance to the next slide. Perfect, there we go. Okay, so what is carbon? Carbon is a fundamental element that's essential to life, but when we talk about climate change, we're usually referring to carbon dioxide or CO2. So CO2 is a colorless, odorless gas released when we burn fossil fuels like coal, oil, and natural gas. It's also produced through natural processes like human respiration. However, it's the extra CO2 from human activities like driving cars, generating electricity, and manufacturing that's really driving global warming today. So let's understand exactly what greenhouse gases are. You'll often see them in the literature as GHGs. CO2 isn't the only greenhouse gas, but it is the main anthropogenic one. So this is the one that's caused by human activities. And CO2 is responsible for a significant portion of global warming. There are other important greenhouse gases. Methane makes up about 30% of the gases in the atmosphere today. Nitrous oxides, refrigerants, and water vapor are all greenhouse gases as well. These gases act like a blanket around the Earth, and they absorb and trap the heat in the atmosphere, which leads to a gradual warming effect known as the greenhouse effect. Global warming potential is often shortened to GWP, and you'll often see that in the literature that you're looking at. So not all greenhouse gases are created equal. The ones I mentioned before, CO2, methane, nitrous oxide, refrigerants, they all affect the Earth a little bit differently. So in order to compare their impact, we use a concept called global warming potential, or GWP. CO2 is our baseline with a global warming potential of 1. Methane, for example, has a global warming potential of 25, meaning it traps 25 times more heat than CO2 over a 100-year period. Nitrous oxide has a GWP of 298, which means it's almost 300 times more potent as a greenhouse gas than CO2. And 410A, which is a common refrigerant, is 2,088 times more potent. So this is an even more important greenhouse gas, but it is operating at smaller levels right now. So there's a lot to keep in mind. So in your work, if you're involved in reading about or working to reduce carbon impact, you'll often see the term CO2e. So to simplify things, we convert all of those gases into CO2e, which stands for carbon dioxide equivalent. This means that we express the impact of each gas as if it were an equivalent of CO2. For instance, 1 ton of methane is equal to 25 tons of CO2e. This lets us compare all greenhouse gases on a single scale and measure their overall impact more effectively. What's really important to understand is that climate change isn't just a natural process. It is, but the distinction between natural climate change fluctuations and human-induced climate change is important. Human activities, especially the burning of fossil fuels, have greatly increased the concentration of greenhouse gases in our atmosphere. This has accelerated global warming far beyond the natural variations that have occurred over time. So now we're going to try and get a bigger picture of what carbon legislation looks like today. We'll start big and then we'll get a little bit closer to home. To understand where we're headed with carbon reduction, we need to start at the global level. In 2015, the United Nations introduced the Sustainable Development Goals, or the UN SDGs, as a blueprint for a more sustainable future. The UN SDGs are a set of 17 global goals to address urgent challenges facing our world today, such as poverty, inequality, climate change, and environmental degradation. They serve as a blueprint for achieving a more sustainable and equitable and prosperous future for everyone by 2030, with each goal outlining specific targets and actions for countries to work towards. However, despite this call to action, progress has been slower than needed, and we're not yet on track to meet these targets. Let's talk a little bit more about that progress on global climate goals. The Paris Agreement, signed in 2015, set a powerful target to limit global warming to 1.5 degrees above pre-industrial levels. But as you can see with this graph, our current policies and actions have us widely missing this target, even with all the pledges and net zero plans made at COP's 26 in 2021. The 2024 Environmental Performance Index shows that emissions in many of the world's largest economies, like the US, China, and India, are either falling slowly or still rising. This tells us that while we've made commitments, we're not moving fast enough yet. However, climate legislation is constantly moving forward, pushing us closer to our targets with each step. So let's bring this even closer to home. Canada has experienced severe climate-related disasters recently, with record-breaking wildfires in 2023 that burned over 18 million hectares. Extreme flooding in Toronto in 2018, 2020, and just recently in the summer of 2024. And devastation has been caused by hurricanes, including Hurricane Fiona in 2022, all across Atlantic Canada. These events underscore the urgency of addressing climate change now. In response, Canada has set some ambitious climate targets. By 2030, we aim to reduce our greenhouse gas emissions by 40 to 45% below 2005 levels. By 2050, Canada has targeted net zero emissions, meaning that any remaining emissions will need to be offset. These commitments aren't just about meeting international obligations, they're about protecting our communities and our future. But it's not just about national commitments. Provinces and cities play a huge role too. For example, Toronto has implemented the Toronto Green Standard, which sets sustainability guidelines for new buildings, ensuring that they're energy efficient and emit fewer greenhouse gases. Other provinces and municipalities have introduced similar regulations, tackling emissions through renewable energy mandates, building efficiency standards, and local carbon pricing initiatives. So while global, national, and local efforts are underway, there's still a long road ahead. As architects and designers and professionals in the building industry, we have the power to turn these regulations into real, on-the-ground change by making sustainable choices in our projects. Back to you, Mike.
I think an important part of the discussions, much like how we use carbon dioxide equivalent to talk across ideas, we're thinking about common languages. So how do we make sure that everybody has the literacy, the common languages to discuss some of these heavy ideas? So we've got these four that we'll go through. So you've probably heard of these, hopefully one or two of these before, but we're just gonna kind of get to the basics and make sure that everybody can kind of understand them in a way that we can talk about them in the next couple of slides here. So first, the carbon footprint. So this is the total amount of greenhouse gases caused by our actions, both directly and indirectly, as a result of things that we make and generate in terms of CO2 CO2 equivalent, that little E, that CO2 equivalent. It includes not just the emissions that we burn personally by living in a building, driving a car, mowing the lawn. It's also about the carbon impact of making the thing itself, of transporting it, and getting that Amazon package into our hands. Hopefully, you've heard people speak about decarbonization, our second item here. So decarbonization, the idea of reducing or eliminating carbon dioxide from these processes. So getting carbon dioxide out of the activities. A big piece of this is through the transition of fossil fuels, away from fossil fuels and into renewable energy resources. We can also increase the energy efficiency and implement strategies that can offset carbon dioxide emissions. The third piece here is carbon sequestration, so sequestering carbon. This refers to a natural process of capturing and storing carbon dioxide. So we take it out of the atmosphere and we put it into things like forests, our soils, and our oceans. So while it's natural, we love to encourage this process through practices like restoration, through soil management, and through conservation. So this can help to offset the emissions that we can't fully eliminate. Next up, we've got scope emissions. So scope 1, 2, and 3 emissions. So the last one here. And I think we just want to cover these in a meaningful way. So scope 1 emissions are the emissions that come from carbon dioxide emissions, or GHG emissions, that come directly from sources owned or controlled by a company. So this is like something like burning fossil fuels to make heat on site. Scope 2 emissions are direct emissions from the generation of purchased electricity, steam, heating, cooling, by a company that is doing something, making something. This can be as simple as, the electricity in our houses, right? It has to come from somewhere. How do we generate that electricity? Through hydroelectric dams, through nuclear power, or through the burning of natural gas? There's one good one in there. Scope 3 emissions are the broadest category, covering all the other indirect emissions that occur in a company's value chain, like those from the suppliers. So the suppliers themselves might use something that is going to generate some extra carbon in there. So that's just a little piece on the kind of key concepts in carbon literacy. And then I think we're going to step into carbon management itself. So, and some things that we know about, and you've probably heard a lot about carbon pricing being probably the biggest one that we hear about in, I would argue, in Canada and Ontario, especially. It's an approach to manage carbon through essentially taxation, right? So we're giving carbon taxes, which charge a fee for emitting that carbon dioxide, making it more expensive for us to pollute the planet and cause climate change. So in Canada, we have a federal policy that's a national carbon tax that sets a price on emissions, which is gradually going up each year. So I know, as the case is in Sweden, it is substantially more expensive in other parts of the world for their carbon taxes. Ontario, Canada, is not at the Swedish level, but we certainly do follow the European role model, and we will eventually be at a much higher value for that taxation. So it also shows that in Sweden, we've got a much higher tax, but it also has led to a much quicker adoption of decarbonization and faster reductions in carbon emissions. So it shows the idea of how carbon pricing, can start to drive some of these changes by creating incentives for people and individuals to reduce their overall carbon footprint. So carbon offsetting, the kind of second piece here. So we've got carbon taxation or carbon pricing, and then the second one, carbon offsets. So this involves investing in carbon projects. So we're going to try and remove those emissions to compensate for any carbon that we might be producing. Common ones are going to be renewable energy, a little wind energy, little solar farm, reforestation, plant some trees. We're going to use those trees to absorb that extra CO2 out of the atmosphere. So offsetting can play a crucial role in managing our carbon emissions when we're looking at overall carbon production. But we do want to make sure that these projects are credible and do make a difference, being thoughtful and intentional in the way that we decide what we're going to do. last little carbon management strategy here is carbon neutrality. So in carbon neutrality, how do we get to net zero emissions? And that's all about balance. So generating carbon and then offsetting or reducing carbon to get to net zero carbon. This can be done by cutting emissions as much as possible. This is where we want to look at really creating efficiencies and then offsetting any extra on the scale, any that's left over. We want to kind of offset that through credible offset projects. So we really want to get to that balance as the Earth is trying really hard to get back to, where all of those processes are at a neutral, balanced level. So a couple things here. We just want to, the idea of some emerging technologies and solutions. I think it is a common thread that we hear, oh, there's this latest and greatest, new thing that's going to save us. And while certainly that can be true, I think we just need to be mindful of just certain language that's used in it in and around decarbonization, sustainable buildings, green building space, all these things. And there's just a couple we wanted to talk about. Direct air capture. So this is one of them. Direct air capture is where we take CO2 directly from the air. Brand new, sounds fantastic, no problem. Better than trees, right? You don't have to plant any trees. We just take carbon out of the air. Cool, right? But still extraordinarily expensive and also energy intensive. So deploying it at the levels that we need, really a lot of work to make a significant impact. The second one here, electrification. So electrification, we're definitely moving things towards electricity instead of fossil fuel burning devices and, furnaces, natural gas stoves, all of these things. Trying to move away from that and switch our fuel from fossil fuels into electricity. So electric fuel, I'll say. But one thing that isn't talked about maybe as much as we should is what is the source of how we're going to make that energy? So what is the source of how we're going to make that energy? And that makes a big difference. So places across Canada have different fuel sources for how they actually generate their electricity. Ontario being relatively what we would call a clean grid. So our electricity is relatively low carbon. Places like Manitoba, even better. Places like Quebec, even better. But then places like Alberta, actually much, much worse. So they use a lot of fossil fuels to generate their electricity. So we just want to be careful there. Carbon capture, utilization, and storage, or CCUS. So we're going to look at how do we take carbon capture, carbon from the industrial source and put it into something. So maybe, I'm skeptical, but that's the point of some of these conversations is I think that we know that trees definitely work. We know that renewable energy definitely works. I think that carbon capture, utilization, and storage, while promising, is a step forward, but it's, again, cost. So very costly and only captures a small amount of global emissions. Hydrogen, super, super hot right now, right? So hydrogen, clean hydrogen, people will say green hydrogen. We've got this fantastic resource. Pretty easy to make hydrogen. We just take a couple molecules of water, split them into hydrogen and oxygen, and not bad, right? That's a pretty easy way to get hydrogen. How do we do that? We need electricity. So that electricity, where is that electricity coming from? And you can see here that that can be a kind of Ouroboros of how much energy are we requiring and how much fossil fuels do we need to make that energy to get that hydrogen. Fourth thing, methane management. So Breanne mentioned that methane is 25 times as potent as CO2. So this is something we can look at, methane management from agriculture. So a lot of our food production is going to be because of methane producing animals, for instance, or simpler, we can think about fossil fuel production because we do use methane for some as a fossil fuel in some things. So just stepping back, I think it's important to advocate and think about the future. We want to advocate for technologies that hold promise for the future, but we also want to remember that they're new, they're emerging, and they're not at scale. They're not at the scale we need to replace foundational strategies. If you reduce the overall carbon at your source, you can certainly reduce the overall carbon, period. We can improve efficiency. We know we can do that. Why would we go to these other strategies when we could just start with the foundational things? And the last thing is what we call adopting circular practices. So that being said, just getting into the big ideas. And then I think next slide, we're just going to look at some of the misconceptions about carbon footprint. So I think this is also important. There's a way that we speak about this decarbonization process, and much in the same way as paper straws now dominate much of our fast food places, we want to be careful with the actual versus the perceived effect of some of these CO2 carbon dioxide emissions. So these are just some examples on the screen here. We've got everything from, recycling as much as possible. We can see here we've got people's perspective on the left. So, recycling is amazing. And then sure enough, the actual carbon dioxide reduction is not as significant as something like not having a car, right? So we want to be mindful. We want to be educated. We want to look to the evidence. We're going to look to the evidence. We're going to look to the data and say, what are the things that have impact? We want you to have impact. We want to have impact, and we want to do things with intention. So when we get at that intention, we can start to look at things that are meaningful, helpful, add value to decarbonize and help the planet come back to where it needs to be. So this, of course, ties back to our earlier discussion about emerging technologies, where they sound promising and they aren't necessarily at a scale to make a massive impact yet. And this really leads us to one thing that is becoming, we'll call it less and less commonplace as of June 2024, and we'll get to that in a second. So you probably heard about greenwashing. So greenwashing, of course, being the process of, the latest and greatest, most sustainable, blah, blah, blah. What's your favorite sustainability color, your favorite green energy color? Always green, right? So in this case, we've got, as an example, Coca-Cola came out with a Coca-Cola Life. Coca-Cola is, of course, a global conglomerate of, companies that do all this stuff to make Coca-Cola and put it in bottles. And I think that when we look at greenwashing, I do wonder what, in this case, Coca-Cola Life has to do with sustainability. And it is something that is commonplace. So as of June 2024, we had federal legislation that has come into effect. That's called Bill C-59. That basically is saying no more greenwashing. So I think that this is an important step when it comes to legislation, but we should also be educated and provide evidence as to what makes something low carbon, right? So, and we're going to talk about that in a little bit, but in that way, I think that this greenwashing legislation is going to be helpful. There are certainly companies that are trying to figure out what it means, and there is definitely going to be some steps forward and some progress made on getting back on track, getting away from greenwashing. So next step, we've got a little bit more close to what we're all interested in here, I think, is carbon in the built environment. So Bree, I hand it off to you for part 2 of our narrative here.
Fantastic. Thanks, Mike. All that stuff that we just talked about is great because it really gives us a good foundation of what carbon is, why it's an issue. And then now we're going to go ahead and talk about carbon in the built environment. But without that background information, it can kind of be hard to scaffold and kind of be hard to understand exactly why we're talking about this stuff. So a little bit about carbon and how it impacts the built environment. So now that you've got that foundational understanding, let's bring this conversation right into the realm of buildings. So why should we as architects be so concerned with carbon emissions in our work? Simply, the building sector is a massive contributor to global carbon emissions. It was mentioned, Mike mentioned it in the outset of this talk, but globally, buildings account for nearly 40% of global carbon emissions. In Canada, buildings contribute to 17% of our national emissions. And in cities like Toronto, they're responsible for a whopping 56% of total emissions. This means that buildings, both in their construction and in their everyday use, are a really big piece of the climate puzzle. There's 2 types of carbon emissions in buildings. So if you look at this graph here on the screen, you've got a whole bunch of things listed in yellow and a little bit listed in blue. So all of the yellow pieces are talking about embodied carbon, and the blue pieces are talking about operational carbon. So let's go into operational carbon first. These are the emissions created when we heat, cool, and, well, operate our buildings. Think about all the energy needed to keep a building comfortable, functional, and lit. In 2022, the building sector accounted for 34% of the world's power consumption. Operating a building creates a lot of emissions, especially when that energy is sourced from fossil fuels, like coal and natural gas, which release carbon dioxide when burned. The other type of carbon emission in buildings is embodied carbon. While operational carbon has received a lot of attention over the years, embodied carbon has more recently been recognized as a pretty impactful part of the puzzle. Embodied carbon refers to the emissions associated with the materials in the building. So all the materials that we use to build, from their extraction and their processing, their transportation, to installation, all the way to the end of their life. All materials have embodied carbon, but materials common in the built environment, like steel, cement, glass, and aluminum, require a ton of energy to make. Also to transport and to install, which generates significant carbon dioxide emissions. So in terms of these two types of emissions, historically, we focused on reducing operational carbon by improving insulation, upgrading our HVAC systems, and using renewable energy. And we've made some really good progress. Today's buildings are a lot more energy efficient than those built in the past. But studies show that embodied carbon, those emissions that are tied to the materials and the construction processes, can account for anywhere between 30 to 70% of a building's total life cycle emissions. As buildings become more energy efficient and grids become electrified, embodied carbon will make up an even larger share, making it essential to address embodied carbon right now. So let's look at some of the strategies for reducing carbon. We're going to look at it both in terms of operational and in terms of embodied. So let's start with operational. This is the stuff a lot of you guys have probably been working on already. We're all developing sort of more energy efficient, low LED lights that are using less energy. So some of the strategies that we can use to reduce operational carbon include passive design, strategies like optimizing building orientation, optimizing insulation, and using thermal mass can all significantly reduce the need for heating and cooling, and therefore fossil fuels. By leveraging natural light and ventilation, buildings can drastically cut down on operational energy use, leading to lower carbon emissions. Implementing energy efficient systems like heat pumps, LED lighting, and smart thermostats can drastically reduce operational carbon, as can renewable energy sources such as solar panels and wind turbines will shift use away from fossil fuels. When we move over to embodied carbon, a report developed by the United Nations Environment Program in 2022 called Building Materials and the Climate, Constructing a New Future, identified 3 key strategies to reduce embodied carbon in your design. The first strategy is to build less. By choosing to retain existing buildings or reuse existing materials, we avoid extraction and production of more new materials. You can choose to minimize material use and prioritize reusing existing structures, some of the main tenets of the circular economy. Second, design differently or shift towards more sustainable materials like bio-based options or low carbon alternatives wherever possible. Third, choose better. Recent innovations are improving the carbon footprint of conventional materials such as steel, aluminum, insulation. Make use of low carbon options and specify those conventional materials only when absolutely necessary. The urgency of designing lower carbon buildings really cannot be overstated, because if you consider that half of the buildings that will exist by 2025 haven't even been built yet, the choices we make today will shape our carbon impact for decades into the future. In order to really address climate change, we have to prioritize near zero emission resilient buildings. This is our opportunity to create great buildings, one building at a time. I want to talk a little bit about sustainable building practices and reimagining what makes a building truly sustainable in the long term. So across the top, we've got, when most people picture a green building, they think of things like planted facades, green roofs, solar panels, and tiny homes. These features are highly visible and they look great, but they don't always represent the full picture of sustainability. They're appealing, sure, but they kind of only scratch the surface. Along the bottom represents things that are a little bit more sustainable, a little bit deeper. So going beyond those obvious features, it's about the concept of densification, making efficient use of space in order to reduce urban sprawl. It's about using healthy and climate positive materials. It's about harnessing a fossil fuel free and renewable energy to power not only our buildings, but the entire procurement process of the materials. It's about embracing circularity, reusing existing buildings and existing materials, designing for disassembly so that materials can be reused or recycled at the end of their life, or repurposed even, and using flexible design so that buildings can adapt to changing needs over time. The circular economy challenges us to think, rather than always building new, how can we adapt and upgrade existing structures? This mindset shift is really important for reducing the overall carbon footprint of our buildings. So while those visible green strategies capture public attention and they're a great start, foundational green strategies, which address sustainability at a deeper level, like circularity, densification, renewable energy throughout the whole life cycle of the building, and material efficiencies, will tackle the root causes of emissions, significantly reducing carbon emissions over the entire building life cycle. Certifications like LEED, Living Building Challenge, Breanne, and the Zero Carbon Building Standard provide frameworks and encourage designers to consider lower environmental impacts. However, these systems often emphasize the more visible features we talked about, such as energy efficiency, water use, and renewable energy, while sometimes overlooking less glamorous aspects, such as material reuse, circularity, or densification. Ultimately, sustainable building practices require us to think beyond the surface level, focusing on a building's entire life cycle, adapting to future needs, and maximizing the value of existing resources. So back over to you, Mike, to talk about how to integrate carbon literacy into your projects.
Perfect. Thanks, Breanne. So I did just post a small link in the chat for anybody who's curious about Bill C-59 as we go here. So yeah, perfect. It's just a brief explanation, but it does exist, of course, on the Government of Canada website, but it's quite long, quite verbose. So nice little introduction there, CCLI. So let's do exactly. So thanks, Breanne. So the role of carbon literacy in building design. So what do we want to do? We've got all this stuff about carbon. First thing, we want to make some informed decisions. We want to make some informed decisions on how we make our buildings. So carbon literacy, what we're doing right here, is about education. It's about understanding. It's about listening. It's about focusing on how we can make design choices through evidence that we know makes a building lower carbon. There are strategies certainly in the design of buildings, the construction of buildings, and through their operation. The second piece is going to be, it's important for you. It's important for the architects and the designers. So our carbon literate professionals, us, we can have impact. We can influence building performance and reduce emissions, again, in the design and construction of the built environment. So I think two kind of sub points here are going to be, we want to empower you. We want to empower architects to communicate the value of low carbon design to your clients and use examples and case studies, again, that can add value and reduce carbon. The second piece is we want to amplify the voices of those who have impact. So you all have impact. We can do this together, and we can together create low carbon, high performance buildings that add value to the built environment and to your clients' portfolios, to your architectural portfolios, and can also, of course, mitigate the impacts of climate change. Second big piece is we've got the role of carbon literacy in procurement itself. So if you've seen RFPs, many more recent RFPs that I've seen will say, especially on public projects, a client will request a net zero carbon building per CAGBC guidelines, which is just our slide here. So CAGBC, zero carbon, or they might even say passive house certification. So there are definitely some pre-built policies that we can be above the code minimum. I don't want to say passive house is above the code minimum. It's quite a bit above the code minimum, but we think that these can help amplify your client's decarbonization story. Another way is, of course, from the designer perspective. So you're in a meeting, you're hanging out with a client, you can start to introduce ideas in conversation, or maybe even at the specification stage, right? Through, you're going to, talk with clients, but obviously we've got the specifications offer a chance to reduce carbon in our designs. And this can range from small changes, like changes to our specifications, simple things like reducing carbon by the standardization of low supplementary cementitious materials in our concrete, in our structural specs, to maybe some things like low carbon production methods for creating steel. So electric arc furnaces, for instance, are now starting to kind of be at the forefront of some great technologies to reduce carbon. This is a way of putting real numbers, real metrics into our specifications to say we want to get at those carbon numbers and get them down. So these are real metrics, and we can use them even in our Division 1 specifications. We can just use the math, the numbers, the stats to target inside of our Division 1, our kind of first specification here, to get down our carbon dioxide equivalent, so that CO2e number in the space of our specifications. So just helpful even as a talking point, but also really great for a contractor to see at the outset, what are your global warming potential targets? What are your greenhouse gas targets? This type of thing. So next slide. So let's just do a little bit on this. So we did talk a little bit about our progress, and I think that it's helpful to have certainly things like net zero in place to start to get at some of these ideas of decarbonization. But I think that we can do better, right? So I think we can do better together. We can do better. We can do better apart. We can do better as designers. We can do better as kind of creating the space for people to understand carbon, creating the space for better buildings. So let's go to next slide. So, just unfortunately closer to home, we've got our mean temperature in Toronto here. October has never felt so warm. And while it's amazing to go for a kind of walk outside, I don't know what it's like today. I haven't been out, but this week has felt very warm for an October month. And while pleasant, points to some unfortunate other challenges. But because we do want to stay positive, we're all staying positive about being low carbon. We want to look at how do we take this graph, and we're really trying to ratchet down the carbon emissions. And I should mention that the whole point of this graph is that the carbon dioxide is creating an increase in temperatures over time. Los Angeles certainly experiencing some big changes, and certainly our second hurricane of right after our first hurricane in the south there, quite a bit of devastation there. So I remember 2007 watching An Inconvenient Truth, and it certainly is becoming more inconvenient. So this is just an idea. So spectacle. Is it raining? So thanks, Lilo. I'm getting the weather updates as we're talking here. We've got just an idea here. So this is maybe a personal perspective, but it's also a common theme about looking at how things get introduced to market. So we have a kind of on the left here, we have market penetration, and this just means how kind of common is it? Does everybody have it? Is everybody using it? And then across the bottom axis here, the kind of x-axis, we have time. So how popular, how introduced are things over time, right? As an example, I'm going to try and make this a stretch. We can think about iPhones or even cell phones. Let's stay away from brand names. The very beginning of handheld smartphones, not a lot of smartphones, right? Pretty skeptical, pretty early. And certainly today, I don't think, most of us probably couldn't live without them. So we've got all the way over here, massive market penetration. So we've got all the way over time here. Certainly everybody's got these pieces. So I think that when it comes to buildings, when it comes to looking at market opportunities, we want to show that there are certainly economic benefits to early adoption. it might cost more, but there are definitely benefits to how that looks. And the point of this graph is to look at how, as we transition to these low carbon technologies, they can allow your clients the space to de-risk future ideas about things like carbon taxation, potentially provide access to green building funding. So we see here, we've got kind of in the middle zone here, information and incentives. So there's a kind of slow track to mass adoption. So there's certainly green, what did I just say? The idea of green loans. Anyway, so the idea of green loans and how to get some funding for some of these low carbon opportunities. And I just saw, as of last year, BMO, other banks are starting to offer some of those funding mechanisms for these more green buildings. And that's definitely something that clients and we should be familiar with as designers to kind of provide some space for people to understand how they can transition early. Certainly being first is challenging, but it also means that you have the most experience doing it. It means that it's going to look really good when that new RFP comes out, and you've got all the experience, and you can take that experience and exercise it. So when we think about decarbonization, high performance buildings, certainly circular design, circularity, but we want to be ahead of the curve. And of course, this is a little bit of how that term has come into common conversation. We want to be ahead of the curve, right? So this is our curve. We want to be ahead of it. Because by the time it gets to regulation, that's late adoption, and that is the minimum that's required, right? So we don't want to be at the minimum. We want to be at the value proposition. We want to be at the best case scenario. We want to be at the most beneficial for everybody involved. So I think that this is just the idea of, so how do we tell the future? Right? How do we tell the future? What is the future of low carbon buildings? We can certainly speculate, but we do know that the temperature is going up. So we need to get it not to go up. So if we do know that the energy is coming, the carbon is coming up, we know that energy prices are going up. There's a little volatility in that space. So things like low carbon buildings mean that we can, again, reduce risk or de-risk some of these climate change pieces. And as for preparing for the future, we've got our x-axis here moving us forward, the arrow of time. We're going to come back to Breanne just a little bit on preparing for the future itself. So Breanne, back to you.
Great, thanks, Mike. So I am cognizant of the time. I see it's 12:51, but this is the stuff that we really wanted to get through to you guys here. The City of Toronto is ramping up its efforts to combat carbon emissions by considering the introduction of version 4.1, TGS version 4.1 in 2025, tightening those greenhouse gas requirements even before TGS version 5 is scheduled to be released in 2026. This potential change really emphasizes the need for all designers to pay really close attention to embodied carbon in their projects. And even if you're working outside of Toronto, adopting these standards now will keep you ahead of the curve, as Mike was talking about, as many municipalities are following suit with strict green building legislation. So here are some ideas you can consider in order to improve your projects today. Number one, start with circular considerations. The first question to ask is, does a new building even need to be built? Can an existing structure be adapted or reused? If constructing new is the only option, can you consider ways to reuse existing materials from that site or from other projects nearby? Number two, prioritize the site selection. If you are building new, choose brownfield or infield sites over greenfield locations to preserve valuable green space and its ecological functions. This is the density that we were talking about earlier. This minimizes disruptions to ecosystems and helps maintain biodiversity. The third move is to optimize your material choices. When procuring materials, prioritize low carbon options like recycled steel, sustainably sourced timber, or other bio-based materials. Use environmental product declarations, often called EPDs, to understand and minimize the embodied carbon impact of your material selections. Number four is design for adaptability and reuse, or disassembly, which is another circular consideration. Consider the entire life cycle of your building, from construction to actually tearing it down. How can it be adapted in the future or disassembled instead of demolished in order to reuse the components. This mindset reduces future waste and maximizes the building's value over time. The next move is to incorporate passive design strategies and energy efficiency. Once you've addressed circularity and material choices, use passive design strategies to reduce energy needs. Optimize your building orientation, the insulation, natural light and ventilation in order to minimize operational carbon. And to finish, embrace renewable energy. Because after you've reduced the building's energy demand, you can explore incorporating on-site renewable energy sources like solar panels or wind turbines to further reduce operational carbon. I mean, maybe not wind turbines on site, but things like solar panels or things like investing into offset projects like wind turbines. So these strategies not only reduce carbon emissions, but they also help to future-proof your projects against evolving building standards and client expectations. By approaching sustainability from this holistic life cycle perspective, you'll create buildings that are genuinely future-proof and climate positive. As regulations evolve and new technologies emerge, continuous learning and adaptation is key, which is what you guys are all doing here right now. So that's awesome. Stay informed about the latest green building practices, monitor updates to building codes, and keep exploring innovative solutions to ensure your projects not only meet, but exceed future sustainability standards. Mike is going to wrap this up and talk about some of the other things Heavy can do for you.
Yeah, so this is the last slide, I promise. And I think we just want to follow up with, if you have any questions about our presentation, we're going to stick around for a little bit, so don't leave if you've got questions. But I think we just wanted to express our gratitude for you being here, and then also offer some ideas about what we do at our very new consultancy here. So if you have any questions or ideas about circularity, so we'd like to help you if we can. Passive architectural design, so some ideas about how we get at low carbon, high performance buildings. So bio-based materials as well, if you need some help generating some ideas about what we can do in our projects. If you had an RFP come in and you'd like to understand maybe a little bit more about some of the parts of pitching some zero carbon projects, we're happy to help with that. And low carbon design in general. So if there are ideas about your buildings, ideas about how you'd like things to move forward, we can definitely help with that. And then, of course, much like we're doing today for you, is workshops, training exercises. My preference is to do things live, but I'm happy to hang out here online as well. So virtual or in person, and we're happy to come and do some workshops. So lots of drawing, lots of pads of paper, lots of discussion, just like school, but I promise it'll be great. So that being said, that just about wraps us up. We are going to stick around. I realize we've only got 4 minutes here for questions, but yeah, of course. So where to follow you? So right now we've got heavyclimate.ca is our website. And if you're on, we should also mention our Instagram here. So at heavyclimate is our Instagram, and feel free to follow us there. It's public. You can hang out there. Trying to post more. We'll try to post more in the future. So thank you so much for the time. And like I said, we'll stick around, realizing we're tight on time here, 3 minutes or so, but happy to discuss or hear any questions, and let us know.
Thank you, Mike and Breanne,
Thanks,
for
guys.
such a valuable presentation. And thanks for all attendees for joining us today. We really appreciate your participation. And if anyone have a question, please go ahead.
Hi, Mike.
Thank you.
Hey.
Great presentation. I wanted to know, does your team plan to expand in Montreal? I worked in consulting in French Canada, and I'm a francophone, so I was just curious about that. Thank you so much, and congrats on launching.
Awesome. So I think being a remote enterprise in the kind of space after COVID here, we're happy to help anywhere. I think that being in person is of course my preference, but happy to chat if you want to send us a note, and info@heavyclimate.ca, excuse me. So thanks, Elias. Yeah. I should say I'll have to start working on my French, Elias. So I did some projects in McGill at University of McGill, but that was a long time ago now. So
Thank you, everyone. Sounds like there are no questions, but we would like to thank you all again, and thank you, Breanne. and-
Sorry, Lulu, may I say one thing?
Oh, go ahead.
Okay. Hi, Mike.
hi, Moses.
Brianne, how are you?
I'm good. I'm good.
I'm fine. I do life cycle assessment for a living, in my consultancy firm as well. One of the biggest problems was, almost all the solutions that we've talked about in this session is that the cost is going to be high. Taking into consideration what is happening currently in the market, I don't think it will be a lot of options we have, especially, for example, when we talk about bio-based materials, which is I do like bio-based materials, but unfortunately, again, the picture is unclear because many of us will say, oh, you know what, we've reduced GHG emissions or global warming potential of bio-based material by 97%, but at the same time, at the cost of increasing water consumption by 150%. And yeah, for Canada, you know what, who cares? We have lots of water, right? But if you started looking into the Middle East, Sub-Saharan Africa, you know, India and other parts of the world, that will be a disaster thing. So how do you think that could be approached?
Excellent question. So I think that much like our energy production we were talking about there briefly, when it comes to every space is different. So I think that in Ontario, of course, we've got relatively clean grid for electricity, but Alberta, of course, not so clean, right? So I think definitely being mindful of what do they call them? Just wash solutions, like kind of like across all spaces and time and effort. I think we need to be mindful of where we're making these things, and definitely, Moses, it's a great point. The environment where the thing is, where our buildings are, is going to be paramount. So every building needs a story. And I think when you're talking about LCA, certainly I'm sure you've seen, does LCA not change between country? Like if you're doing an LCA for a building in Toronto, is it different from doing a building in Abu Dhabi, for instance, or anywhere? Sure. I'm curious, actually. I don't actually know the answer to that question, having mostly worked in Ontario. So we can certainly chat more. It's a great question.
My pleasure. Thank you.
Thanks, Moses. Yeah.
Great. Thank you very much.
Thank you, Washdi. Thank you, Laloa.
Thanks,
Thank you,
everyone, for
everybody.
having us.
Thank you, guys.
Have
Thanks,
a great day.
Moses.
Thank
Look me
you,
up on
Breanne.
LinkedIn.
Thank you.
I'll be in touch.
That's for sure.
Thanks, Moses.
Thank you. Bye-bye.